I'm here at Area 419. I'm here with Craig and Justin. We're going to walk you through the process of taking these raw materials and producing the Zero Press. You guys ready for this?
Let's go do it.
All right.
Absolutely.
So what do we have here, Justin?
So the first step in the process is the machining of the body.
Yep.
So what we have here is our bodies in these vices here. It starts out as an extruded piece.
Yep.
And then it gets loaded in the machine and it machines out the first op of the body.
So this is highly optimized. How much material on average are you taking off to get to your nominal dimensions there?
So this, great you bring that up. It used to start, before COVID, it was a single plate at, a 9-inch plate.
Yep.
And we got to a volume where we could just get a die made, an extrusion made, to cut down the waste. So
and machine time, right?
Machine time, definitely.
Yeah,
So
absolutely.
we went from, when we first started making these on the Haas, it was a 30-minute program. Then we went down to about a 22-minute program, and now we're down to 18 minutes.
Wow.
Just by removing that with near net extrusion.
That is amazing. So the robot knows where to pick up a blank,
Yes.
puts it in. What do we got here? What is this machine?
So this is our Grobe 350, our 5th axis machine.
Okay.
So this allows us to get into all the different ports, the different holes inside that handle all of the different, be able to mill it better than on the horizontal.
Something that's really important too in doing this with 5-axis is we have a handful of parts or locations or holes or bores on a zero body that need to be in a very exact location and relative squareness, parallelness, perpendicularity to one another.
Right.
And doing that in one operation is very important to making sure that part after part, they're correct. So this part, specifically the zero body, it has to be a 5-axis part. Refixturing in a 4-axis or a 3-axis machine is not going to give us the level of consistency we need.
You want to clamp it once, do all of your key ops.
Yes.
You know what your tool offsets are. You know that material's not moving because it's getting reclamped.
The number one place that you're going to pick up tolerance stack in something like this is a refixture.
Right.
You buy good machines, they make parts that are similar to one another from part to part.
Yep.
So being able to hold them in 5-axis and then automate that lets us not only make each part really, really good next to itself, but hundreds and thousands of parts very, very good next to one another in an efficient period of time.
Yeah.
So the robot picks up the blank, puts it in the machine, it comes out looking like this.
Yes.
That is,
Yeah, that is your finished good.
it looks amazing, I'll have to say. Like, the surface finish is outstanding. Wow.
So then, like Craig said, all the key dimensions were done in Op 1. So on Op 2, all we are doing is decking off the back, reprofiling, and then cutting in the Arc-A-Lock on the back, and that's all. So nothing where the mating parts match, it's already been done in Op 1.
This is amazing.
Let's get this machine back to work.
Okay.
Turn her back on. So to turn the fence back on, it's all laser. You make sure it's clear. Give me this button.
Okay.
Now reset fault. Hit play. Fence is secure. Robot's working.
I'm making zeros.
Good job, Gavin.
What was this about?
So what it's doing is it's clearing off that mating part between the vise and the plate to make sure there isn't anything in there.
No chips or
It's
anything.
an air blast off the robot.
Yeah. Interesting.
All right, let's go make more parts. So we made all of these zero bodies on the Grobe. They're coming here. This machine is profiling off the back and giving you Arc-A-Lock. That's kind of the last step there before
That's the
coating.
second op we talked about.
Yep.
But then we also need to make the arms, the mounting plates, the primer trays, the turrets. They work roughly the same way. This is our fixture for arms and primer trays and mounting plates. And the way that all of our fixtures work generally are 2-op fixtures. We might have a 3-op fixture somewhere.
Okay.
But you know, we're gonna feed this machine, like for the arms, this is just a rectangle.
Yep.
It goes in, we do a first op. When it comes off the machine, it looks like this, you know, all this work's done.
Yep.
We then flip it, put it back into the machine like this, clamp it down,
Yep.
and then after this tombstone runs,
So when you guys are designing the machine, you're thinking all this through, right? You're thinking
You
about
have to.
design for manufacturing.
something John does so well.
That's all matching set too, so that's one press on that tombstone. We've got 2 arms per press, so we've got to have room. That's why there's 4
Gotcha.
pieces there. and
Each
there's
of
only
these
2 on the
faces
other.
gets you 1 press
Gotcha.
each time you go of arms, primer tray, and store in the base, the mounting
mounting
base.
plate.
Gotcha.
And that's something John does so exceptionally well, you know, that he is designing and drawing the parts as well as the fixtures and the work holding. When he's designing something, he's thinking about, we have to make this.
Right.
It has to be makeable. You have to be able to hold it.
Yep.
Can it be done in 2 ops? Does it require 3? Is it a horizontal
Yeah.
part? Is it a 5-axis part? Is it a square part we're gonna make on a lathe with live tooling?
And you don't have separate production runs, and you don't have to match the part counts because they're done
They're
in
pre-matched.
sets. That's
Exactly.
really cool.
So as this comes off, you know, this arm is done, ready to go. It's gonna come out of
Yep.
the machine just like this, and it's ready for anodize.
Okay. And what type of machine is this here?
This is it's a horizontal. It's a NHX 5000 from DMG Mori. The 5000 is, it's a 500 millimeter pallet.
Okay.
So these are our bigger pallets, bigger tombstones. The 4000 holds more in the pallet changer, but they're a touch smaller. So on this machine, you're gonna see really big stuff like this, or our Arc-a-Lock clamp fixtures that run 72 clamps at a time, or the turret fixture. I mean, we don't have one in right now, but they're quite large.
Right.
So this machine is mostly running the really large footprint products
Yep.
that are 3/4 axis.
So on these machines, there's a lot of different cutting tools that you need, right? That are part of the process that come in and out of the machining operations. What is the range from a small number of tools to a large number of tools in a tool changer for all of these
So
machines?
our tool changer here has 250 tools in it.
250 tools.
Yeah. So, and the nice part is these run overnight, you know,
Yeah.
unmanned. So what happens is they're also doing tool checks. So they're running that tool across of a laser beam, bloom laser, and it's checking those. And if it's bad, we have then backup tools in there. So it says, okay. Let's put the backup tool in.
Too much wear or breakage or whatever it is.
There's, you know, when you're dealing with putting these on the tombstone, you're dealing with a human error. We don't deal with it very much, but if a clamp doesn't get tightened down, that's gonna ruin your tool.
Wow.
So,
Just mind-boggling. I'm using probably 5 tools on my manual lathe to build a rifle. You know, it's a whole different world.
Yeah, it's nuts.
Nice. Okay, where to next?
Let's go into turning.
Okay.
So the next part that we have that we're going to show you how we make is the pull stud that goes in the top of the turret.
Okay.
These pull studs are A2 tool steel. When we make them initially, like Justin's got there, a full slug.
Okay.
Honestly, when COVID got weird, this was the hardest thing for us to find. Not a lot of tool steel being made in the U.S.
Okay.
And we're only using American raw material.
Gotcha.
So we're going to robotically feed these slugs, and in this operation, we're doing the rough turn. So this is still too large to be used. So we oversize it, send it out to heat treat.
By like thousandths of an inch?
Yeah, I think this is probably right now about 10 thou over
10 thou
everywhere.
over, okay.
Goes out to heat treat, gets hardened, and then actually grows a little bit there.
Yep, okay.
We then bring it back, feed them back into the same lathe with different specialty tooling.
Okay.
And do what's called a hard turn. And with a hardened piece, we will turn it to its exact dimension.
Gotcha.
We can't just make this to the right dimension and then send it out to heat treat and bring it back, because this is enough material that the growth rate of a material this size isn't hyper consistent.
Right.
And this is a part, you know, on any given item, we have a handful of parts that need to be exactly right.
Right.
And then a lot of other things that might have some space. This one has to be exactly right.
Well, you can tell when you drop the turret, and it's a pretty close fit there.
Yeah.
Yeah.
and even when the wedge comes in and draws that down.
Yeah.
So we've got Bob doing a changeover. You see that you know, we've got
cool.
one that's finished.
Yep.
So he's going to put in the fresh slug. We have
Oh, so this does a handoff on
yeah,
this machine?
you know,
Right.
he's going to drop one in, reach over, grab the other one. And he's slow because we're standing close to him. But the reason we have robotic automation in lathes where you typically just use like a bar feeder is there are certain items you can't bar feed slugs. And we also wouldn't necessarily want to drop something this big and heavy through a parts catcher. Doesn't make any sense to do it that way. So he'll go in, he'll drop that piece in. It's now grabbed by the main. He's set. He'll then flip. He's going to grab that rough turned item. After he's got it, release the chuck, pull it out. And as soon as he is clear of the door, yep, he knows he's clear. Door closes.
Wow.
He's going to take that part, sit it back in the tray, grab his next one, and we're working inside the machine. Bob's doing his handoffs, and here we go.
And it's not faster, it's just consistent. You know, I'm not paying someone to stand here and load slugs.
Right.
Noah could have absolutely changed that part faster.
Yeah.
But he's also tending the machine behind you.
Sure.
Or, you know, you go to lunch or you go to the bathroom or somebody's talking to you, and, you know, the fact that the robot is going to feed that part every time.
Night shift, right?
Yeah, all night long, on a Saturday morning or a Sunday morning if you want them to.
Yep.
For us, automation's not about removing the opportunity for jobs. It's about having each individual be able to do more at a highly efficient rate.
Yeah, absolutely.
We're not hiring a robot and firing somebody.
Right.
We're hiring a robot so that the individual that's already there can do more and more and be more productive.
Yeah, absolutely. Makes sense.
So this machine also handles our internal bearing that's Teflon coated. We actually trim that down and split it in half to make 2 bearings. So we separate it with a spacer in between there on the internal.
So we walked through kind of the basic manufacturing of some of the big parts. Obviously the internal bearing is something that is on the same machine that the pull studs are made on, so we didn't get to see that run. But you know, the basics of how all the parts go from bricks to appropriate forms, we went through.
Major components.
We make 22 parts.
Okay.
For the Zero.
Gotcha.
And then the other bearings and things like that.
Yeah, some bearings,
some basic hardware for mounting it. There's about
ball bearing, drill bushing,
45 pieces
a couple springs. But those parts are all made, and then we actually have a suite of, and we're going to show them to you here, specialty wooden crates that allow us to pack up and send these things out to coating and treatment and be protected.
There's your crates for the mounting plates.
So these turret heads,
we
manufacture them, we pack them into these crates. They're custom made for this. They then go to our anodized partner. We pack them up LTL, screw them down, bolt them closed. They go out, they get coated, put back into the same crates, shipped back to us, and that keeps our scrap rate and our blem rate down as much as it can be.
Gotcha.
Everything.
So why are these holes not anodized?
Great question. I was about ready to point that out. The reason is because you need to be able to rack these. So a lot
while they're being anodized.
While they're being anodized. So, you know, we ship them an entire crate. So they requested screw holes someplace. So we put them here because as soon as the pull studs pressed in, they're hidden. No one even knows they exist. But for us, the anodized, you know, if we're racking them in here, then you're going to have racking marks in there.
Sure.
So a lot
like
of
Cerakote, right?
Yeah. Exactly. And we've had to learn. That's been a learning process for us when we design products. We're like, oh, this is a great product. But then all of a sudden it comes back from ano, and we were seeing marks or scratches. And so we had to come up with a way that helped our partners produce a quality product without blemming these out. These are expensive pieces, 70, 75. So, but that's why those holes are in there.
Yep.
Everything goes to coating, comes back, it's ready to go, and we've got a full assembly station back here dedicated to presses. You know, we've got Lily, who is the press master, mistress, you know.
Hey, Lily.
Nice to meet you.
Nice to meet you.
And there's a whole suite of tools here with pneumatics and, you know, hanging fixtures and power tools, to the point that one of our goals with the assembly team, and really anybody in the building, no one's job should be hard. You need to do your job well, and there are things that you need to know how to do with specialty. But anytime we can make a life easier, let's do it. You know, this fixture is totally built to, with pneumatic pressure, push a pull stud into a turret. Because it's a press fit, it's an interference fit. We're smashing that pull stud down into a hole that is fractionally smaller than the stud, so it stays all in
So
one.
instead of hanging off an arbor press,
Right.
you know, she can just simply push down.
Yeah.
And like here, you put a whole body in here, and this is a bushing that goes in the top that guides your turret. And then these drill bushings, the ball bearing in the back that allows you to time the head.
Yep.
But those have to be pressed into the body. So we've got a tool here that we can
Nice.
press here into the body, you know, hit the downstroke, and those push with a great deal of force.
Nice.
And make everything go together. And you know, we've got another one that's for the bearings that push down into the arms. So all of this custom tooling and fixturing is an exercise in, we have to do something that's difficult over and over. How do we make a machine do it?
Sure.
Because, you know, as much as Lily might like getting a workout, you know, we don't want her to have to.
Yeah.
So, you know, back here, this is a process that everything comes together. You know, we'll have sub-assemblies in this process. So a sub-assembly is taking a linkage, putting your ram in it, driving your pin through, making sure all your bearings are in, and now this sub-assembly is complete. Or another sub-assembly is putting a pull stud into a turret so that Lily can either work on certain sub-assemblies or she can do final assembly. And in final assembly, she's going to take a body that has some things done to it, you know, the bushings are in the top, hang it from one of those posts, and then she can part by part put it together, feel everything, all her tools are in front of you.
It breaks
power
up the
hand or
monotony
otherwise.
as well.
Yeah.
You know, like
and that's
one
where
day
your
she
arc
can do
lock
that.
comes in, is right there.
Yeah.
Yep.
Yep.
And we hold them and they float, and these are nice that, you know, these rotate.
Yeah.
So depending on what needs to be accessed, you can be straight up. You can flip it upside down if you're putting bearings in and working underneath. You can get to the side for torque.
Yep.
You go, Craig.
So yeah, if we start building, put a press
So this
in,
is clear anodized on this guy?
Yes.
Yeah.
and that's ready to be worked, ready to be assembled.
Nice. Custom.
Yeah. After they're made here, they then go into box.
Zero top plate.
Ooh, nice.
Press is all wiped down, goes in cleanly. You know, when we built the second expansion here in the shop, this next 20,000 feet, a lot of what needed to happen was the space that we're in now for assembly. We needed the space, it's big. When we're ordering this foam, it's an entire semi at a time. It's pallets of boxes.
Yep.
Part of being a shop that goes all the way from, hey, we got an idea, to that brown box, you can put a label on that and UPS will pick it up and go to your doorstep. You know, getting all the way through that requires a lot of stuff and people
Oh, yeah.
and space. So typically you think, oh, a place like Area 419, they're building on, it's for a bunch of new machines. It wasn't. It was for all of the other things, the less sexy stuff that you don't see so much of that
Yep.
is vitally important
Packing
to what we're
materials, storage.
Absolutely.
Yeah, all of that stuff.
It's boring, but it's an absolute requirement
Yep.
to do business and do it well.
And people may think this is excessive, but I'll tell you what, from a customer service standpoint, we've never had any shipping damage because we're spending the money on this foam.
And shipping damage is such a thing. Yeah, and then you have a piece of artwork for the wall.
Yeah, people hang them on walls. We've shipped more than 5,000 of these things to something like 30 countries.
Wow.
And never, not one time, had a person get there and be banged up. The box might be banged up. We've
Sure.
had people complain that, you know, why is my box all beat up?
Yeah, Ace Ventura type action going on.
Welcome to
Yeah.
shipping.
Yeah, yes, yeah.
But the press is great. The press will be
Nice.
in great shape.
Yeah, because once it leaves here, the people that care about it, between here and the end user,
Yeah.
they don't care about it.
They're annoyed that the box
So-
weighs 30 pounds.
Yes, so they're throwing
Right.
it around.
So that's how we make them. I mean,
Nice.
it's a process that includes a lot of, you know, figuring out the first round of them was a monster.
What I think is interesting about all of this is it's very much up to date. You're using machines and automation for what is best suited for those types of machines and processes. And then you're using the human eye and the human sense of feel to do things that need human attention, but then also automating the parts that are going to give people repetitive stress
Sure.
and make their job a pain in the neck, you know.
You know, everything we make, be it a product or a process, it cannot be a one and done. The Zero that you buy today and the Zero that you received in September of 2020, they're not the same. We've gotten better, and there are little iterative improvements. And obviously we make them. When we find a way to make something better, and we're typically just going to roll it in. Same thing happens in process. we find a different way to put something together, a different tool we can use, a different piece of packaging, a different, whatever that might be, obviously we're going to continue to do it.
Yep.
Because sitting and resting and saying, yeah, we did it once and it worked, it'll be fine.
Right.
That's a good way to go stagnant and die.
Absolutely, yeah. It's really, really interesting stuff. Well, thank you, Craig, and
Yeah.
thank you, Justin, for showing me this amazing facility and the process to make a zero press. When you get a product like this, it's hard to imagine really what goes into it, and it's a little bit mind-boggling to see the investment that you guys have made in the design, in the process, in your team.
Yeah.
Great, great work.
Thank you.
Thank you.
Yeah, and here's what I'd like to know from you all is, what did you think about the process? Do you have a zero press? What are you using it for to load? What are you shooting? Drop a comment and we'll start that discussion. Thank you very much for watching. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you want to learn lucrative gunsmithing like what I show here on the channel, including building custom rifles and Cerakote plus a whole bunch more, you're going to want to check out the Colorado School of Trades, schooloftrades.edu. Thanks again for watching.